Hello, today we're going to talk about parallel and perpendicular lines, a little bit more specifically, really more the equation of parallel and perpendicular lines and how the slope is affected and stuff like that. We have previously talked about horizontal and vertical lines, which are parallel and perpendicular to each other in different ways. So we've used this little acronym. Remember, this part is about horizontal lines with a slope of 0 and a y equals equation. And this part is about vertical lines with an undefined slope and an x equals equation. But now we're going to talk about the formal equation of parallel and perpendicular lines. So if lines are parallel if they have the same slope. So I'm going to write it like this: m equals the same if they're parallel. Okay? If they are perpendicular, the slope is, I'm going to write it like this, is opposite reciprocal. Okay? And what that means is that opposite is plus or minus. So if it was positive, now it's negative. If it was negative, now it's positive. Reciprocal means flip. So you're going to flip the fraction over. So the slope of a perpendicular one is opposite reciprocal. Okay? And this is the symbol for parallel. Here, I'll write this at the top. The symbol for parallel lines looks like this. Kind of like those two L's right there. This means parallel. And this is the symbol for perpendicular. Remember, parallel means that the lines will never touch, and perpendicular means that they intersect at 90 degrees. All right, so if you are given coordinates, you're going to find the slope for each line and compare. Remember that for that you would need to use the slope formula. The slope formula, m equals y minus y over x minus x. So you'll need to do that twice, one for each line, and then compare them. If they are the same, the lines are parallel. If they are opposite reciprocals, the lines are perpendicular. And if they are neither of those, then they are neither parallel or perpendicular. All right. The more difficult kind is if you are given equations. So if you're given equations, you're going to want to put the equation into slope-intercept form. Slope-intercept form is the y equals mx plus b form, where you might have to rearrange the equation to begin with, but it needs to end up with y equals and then the rest of the equation. After you do that for both equations, you're going to locate the slope. The slope is in front of the x. This is the slope. So you'll kind of pull those slopes out and compare. If the slopes are the same, it's parallel. If they are opposite reciprocals, it's perpendicular. If they are neither, it is neither parallel or perpendicular. All right, so let's look at some examples. Okay, are AB and CD parallel? Well, let's look. I'm going to do these in two colors, A, B. We're going to use the slope formula from up here, y minus y over x minus x. We have x, y, like that. So y minus y, 3 minus 6, over x, negative 2, minus x, 2. All right, simplify. 3 minus 6 is negative 3. Negative 2 minus 2 is negative 4. And when you have both are negative, that really means they're both positive. So the slope of AB is 3/4. All right, we're going to do that process again now, this time for CD. Again, x, y. For CD, we're going to use that same formula. Y, 0, minus y, 3, over x, negative 1, minus x, 3. 0 minus 3 is negative 3. Negative 1 minus 3 is negative 4. Since they are both negative, they're really both positive. So the slope of CD is positive 3 over 4. Now we compare slopes. Both of them have a slope of positive 3 over 4, which means that these two lines are parallel. Goodness, I don't have much room. I'm just going to write parallel right here and circle it. Okay? If you think you understand the idea, then I would recommend going ahead and working on this one. Pause the video and do this problem and see if they're parallel, perpendicular, or neither. If you're still kind of confused, then I'm going to go through it with you anyway, so just keep an eye. Here we go. For AB, we're given 2 points. We have x, y, x, y. So for AB, we're going to use that slope formula from up here. Y minus y over x minus x. Y2 minus y4 over x0 minus x5. Okay? 2 minus 4 is negative 2. 0 minus 5 is negative 5. So both are negative, so the answer will be positive. The slope of line AB is positive 2/5. Now we'll do the slope of line CD. Same formula, y minus y over x minus x. X, y, x, y. Y minus y over x minus x. Okay? 8 minus 3 is 5. 1 minus 3 is negative 2. There's one positive, one negative, so this is the slope. All right, now we need to decide, are they parallel, perpendicular, or neither? If they were parallel, the slopes would be the same. Are these the same? No. If they were perpendicular, they would be opposite reciprocals. Opposite means one needs to be positive and the other needs to be negative. That's true. Reciprocal means the numbers are flipped upside down. So here we have 2 over 5, and here we have 5 over 2. This is an example of opposite reciprocal. So these are perpendicular. All right, and you can tell that just by looking at their slopes. This is how you do it when you are given coordinates, when you are finding the slopes. But here we're given equations, so let's check those out. In order to figure out if they are parallel, perpendicular, or neither given equations, you're going to follow these steps. 1, put them in slope-intercept form. That means y equals. Let's look at example A. Y equals, good. Y equals, good. Step 1 is done. Step 2, locate the slope. The slope is always the number that is kind of smushed together with the x. It's multiplying with the x. So I'm going to go ahead and highlight the slopes. Okay. And now step 3, compare. So we want to see, are they the same? No. So they're not parallel. Are they opposite reciprocals? Opposite means one is positive, one is negative. Yes. Reciprocal means the numbers switched places, up and down. Yes. So these are perpendicular lines. Okay, let's look at the next one. Step 1, put it in slope-intercept form. We want them to be y equals. Well, right now, they are not in y equals form. So we're going to rearrange, following the rules of solving equations, to get the y by itself. So for this one, we're going to subtract x from both sides. So we have 6y equals. These are not like terms, so we cannot combine them. I'm going to write negative x plus 30. Next, we have 6 times y, so we need to divide by 6 to get y alone. That means we divide everything on that part by 6 also. So our equation is y equals negative 1 over 6 x plus 5. This is our first equation. All right, now it's in slope-intercept form. Let's look at this one. This one is not y equals. It's 3y equals. So we need to divide everything by 3 to get the y alone. Y equals 6x minus 2. I got these numbers by dividing. 18 divided by 3 is 6. Negative 6 divided by 3 is negative 2. All right, so now we have these in slope-intercept form. We need to locate the slope. The slope is always what's with the x. So we have negative 1/6 and 6. Clearly, these are not the same. Okay? Since they are not the same, that means they are not parallel. We have a positive one and a negative one, so maybe they're perpendicular. And now we need to check for that reciprocal. Remember, this reciprocal means we're switching them. This one we could put over 1 just to make it into a fraction. Are negative 1/6 and 6/1 opposite reciprocals? Yes. So these are also perpendicular lines. And I didn't do that on purpose. I should have done a parallel one. But that's how I did it by accident. If they were parallel, these would be identical. They would both say the same. All right, and then let's look at C. Step 1, put in slope-intercept form. That's y equals. Well, this one is great. It's already y equals, but this one doesn't even have a y. So hopefully you're like, bing, 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 bing. I remember that these are special equations. And like I mentioned at the top, we have a oy vux, right? So this part talks about equations that are y equals. See the y there? Y equals make horizontal lines. Horizontal means this. And the slope of a horizontal line is 0. That's what the O equals. Okay? As far as the vux, it has x equals. That's what that x is for right there. X equals means you have a vertical line, and the slope is undefined. Okay? So this is a special case. 0 and undefined are actually opposite reciprocals. It's just a special one. So these are also perpendicular. And you can kind of see that a horizontal, what I'm talking wrong. A vertical line and a horizontal line would be perpendicular. Okay? I think I'm going to stop there because that got long. I'll probably make another video about this problem here at the bottom. So don't worry about that one right now. Right now, I just want you to be able to tell if lines are parallel, perpendicular, or neither, whether you're given points or you're given equations. All right, see ya.